cation exchange capacity, right? Did you finish that practical, no? Cation exchange capacity?
Yes, ma'am.
Yes, ma'am.
Okay, so can you tell what is cation exchange capacity? A simple definition. Any one of you?
The amount of exchangeable cations per unit weight of dry.
Okay, very good. Amount of exchangeable cations per unit weight of dry soil. Okay, for the cation exchange capacity, we did some procedure now. Can you remember that procedure? Yes or no? Can you remember that procedure? Or the principle? Principle of the cation exchange capacity determination? You can use your notes and tell me.
Replacing all exchangeable cations by ammonium ions.
Ammonium acetate. Right? So we used one solution to exchange the cations that is present in the soil surface. Right? Here also we have to do like that. To determine the total exchangeable bases, we have to follow the same procedure to exchange the cations. Okay. Here we have to see only the exchangeable bases. Right? You all know some are acidic cations, some are basic cations. Okay, so here in this practical, we are going to determine the exchangeable bases. Right? So can you tell some basic cations?
Na plus, K plus.
Okay. Sodium, potassium. Then other things?
Barium 2 plus.
Okay. And other one?
Cesium.
Cesium. Those are the. Okay. Whereas iron, that one a basic cation. I'm asking the basic cations. Okay, so the main basic cations here we considered are the calcium, magnesium, potassium and sodium. Okay, so these are the basic cations that is needed for the plant growth. Right, so for this practical, just we are considering these things. Okay, other basic cations are present in very low amount, no? Am I right? Yes or no?
Yes, ma'am.
Okay. So here just we are going to determine some basic cations. Okay. So here they give a simple definition for total exchangeable bases. Okay. So that is the amount of basic cations in the exchangeable complex. Okay. So you can observe in this picture the exchangeable sides of the soil colloid. Okay, so the total amount of basic cations that can be exchangeable in the soil colloid surface. Okay, so with that we can find the base saturation. Okay, after finding the total exchangeable bases, we can find out the base saturation. Okay, so using the data of total exchangeable bases and total cation exchange capacity, we can find the base saturation. Okay, so there is a simple equation to find the base saturation. Okay, so that is that total exchangeable bases divided by total cation exchange capacity multiplied by 100. Okay, so this base saturation, it will come in percentage. So with that, we can predict the properties. Okay, so like previous practical, so every analysis we are doing for a purpose. Okay, so in your theory part, you will study those things. Okay, so now are you clear about the term exchangeable bases?
Yes, ma'am.
Okay. So you can see some information you can get from determining the total exchangeable bases. Okay, so mainly we can find the fertility level of the soil. Right? Then also you can predict or find the amount of lime that should be added to neutralize the acidity. Okay, so these are the information we can get from determining the total exchangeable bases. Okay, so the main objective of this practical is to determine the total exchangeable bases using a Titrametric method. Okay, so we are going to use the Titrametric method to find out the total exchangeable bases. Okay, so please be careful. This may comes to your exam. That may be to your titration exam or your written part. Okay, so please be careful when you are studying this practical. Okay. Okay, so then let's see the principle of this experiment. Here we are going to convert the basic cation oxide into chloride. Okay, so we are going to add HCl to convert the oxide into chlorides. Okay, so that is the first principle, conversion of basic cations oxide into chlorides by treating with hydrochloric acid. Okay, so then we have to determine that amount of hydrochloric acid that is used by the titration. Okay, so here we have to determine the amount of hydrochloric acid that is used. Okay, for that we have to use a base. Okay, so this is the acid-base titration. Okay, so can you able to understand this principle?
Yes, ma'am.
Okay, so let's move into the procedure part. Okay. Okay. Okay, if you see the procedure, for this you have to get the leachate. Okay, so this one, after doing that cation exchange capacity practical, we can get that leachate. Okay, so you all know the procedure to determine the cation exchange capacity, no? For that you have to take around 1 gram of soil and you have to add ammonium acetate solution, and you have to allow some time for the exchange of cations, and then you have to filter that solution by the Buchner funnel. Am I correct?
Yes, ma'am. Yes, ma'am.
Okay, so from that you can get a leachate. And all of you remember that procedure? Okay. So you can observe some amount of leachate. This should be taken in a beaker. Okay. So then after collecting this leachate, you have to evaporate that leachate. Using a hot plate, you have to evaporate that one. Okay. So this is the first procedure. For that, you have to collect the leachate from the cation exchange capacity practical. Or otherwise, you can do it. Okay. So I think this time you can't do this in your practical classes because it will take so much of time now. If you give time in future, you can do this practical as physical. Okay. Okay. Then after the evaporation, you have to transfer that that residue to a porcelain basin. You can observe in this picture. So this is the porcelain basin. You can transfer that residue to the porcelain basin. Okay, so you can use the hot water to transfer that residue into the porcelain basin. Okay, if it is not dissolved in the hot water, you can also use glacial acetic acid. Okay, if it is necessary, you can use the glacial acetic acid. Otherwise, hot water is enough. Okay, so first you have to collect the leachate and then you have to evaporate that leachate using a hot plate. And after the evaporation, you have to collect that residue and you have to dissolve that one in a hot water and you have to transfer that into a porcelain basin. Okay, so carefully observe these pictures because these things you will expect in your spot exam. Okay. Okay. So this is the second step. Okay. Okay. So then you collected that residue in the porcelain basin. Okay. Then after you have to again evaporate that residue. Okay. See, one person unmute. 085. Okay. Okay. So after the evaporation, you have to keep that into the muffle furnace. Okay, so you can observe the muffle furnace here in this picture. You have to keep that one at 500 degrees Celsius for 30 minutes. Okay, so here we are doing this ignition procedure. For what purpose? Okay, so that is the main function of muffle furnace. Here in this experiment, why we have to ignite the sample? In the leachate, you got the cations, no? Yes or no?
Yes.
Yeah, previous steps, you got the leachate and within that leachate, it will consist of cations. Okay, so after the evaporation, the cations present in the residue. Okay, so now we are going to ignite the residue using the muffle furnace. Okay, so I'm asking what is the purpose of ignite the residue? Any idea?
Oxidize the cation.
Sorry?
Oxidize the cations.
Yeah, very good. To oxidize the cations, because we have to oxidize that cation to convert it as the chloride form. Okay? So by ignition, we can convert it as oxidized form. Okay, so please note down these things. You have to include this thing in your discussion part. Okay, so what is the purpose of ignition of this residue? Okay, so only 30 minutes is enough to ignite the sample. Okay, so then after the ignition, you have to take out the sample and allow some time for the cooling. Okay, so after that, you can add 0.2 m of HCl. Okay, so here we will add around 20 milliliter of HCl. Okay, so 0.2 m of HCl we are going to add. Okay, so what is the purpose of adding HCl? Do we have any idea? So after the ignition, you got the oxide form of cations. Then after you will add the 0.2 m of HCl. So what is the purpose of adding that HCl?
Neutralize.
Neutralize.
To convert the chloride ion.
Yeah, very good. To convert it to the chloride ion. Okay, so we are going to determine that ions now by the titration. I already told you in the principle. Okay, so the ignition we are doing for the conversion of cations into oxide, and then we are adding this HCl to convert that oxide to the chloride form. Okay, did you all understand the purpose of adding HCl?
Yes, ma'am.
Okay, so then after adding the HCl, you have to cover it with a watch glass or other lids. Okay, so you can use that crucible cap or using a watch glass to cover the crucible. Okay, so what is the purpose of doing that one? After adding the HCl, you have to cover the crucible. So what is the purpose of doing that one? Any idea? No, any idea? So after adding HCl, you already told it will convert the oxide into chloride. Okay, so what will happen to the HCl? Sometime it will evaporate, no? HCl?
Yes, ma'am.
Okay, so to avoid that evaporation of HCl, we have to cover it. Okay, so using the lid of the crucible, or we can use the watch glass. Right? Okay, so please note it down, that one, why we have to close the crucible. Right? Okay. So then after, you can mix that one using the glass rod, and then you can keep that one into the water bath. Okay, so you can observe the water bath, and already you all know the handling of water bath, right? So what is the purpose of keeping sample in water bath?
To provide uniform temperature.
To
Provide uniform temperature.
Okay, so to provide the uniform temperature. Okay, so here we need a uniform temperature to digest the sample. Okay, so I already gave it here. Digest on a water bath for 30 minutes. Right, up to this you all understand the procedure?
Fine.
Okay. So then after that, you can titrate. Okay, so you already get the sample in a crucible and you can transfer it to the porcelain and you can directly titrate that solution. Okay, here for keeping the sample in the muffle furnace, you can transfer it to the crucible or you can directly place the porcelain basin. Okay, if you place the crucible, you have to cover it by that crucible cap, or you can cover it the porcelain basin by a watch glass. Okay, so please carefully see the pictures. Okay, so this may appear in your spot examination. Right. Okay. So you all know the titration procedure. Okay, for the titration, you need a titrant and indicator to find out the endpoint. Okay, so here we are going to titrate this HCl and the sample against the 0.1 m of ammonium hydroxide. Okay, I already told this is the acid-base titration. So this is a weak acid or strong acid? HCl.
Strongest.
Okay, so then ammonium hydroxide?
Weak base.
Weak base. Okay, good. Okay, so then what is the indicator we can use for this titration? You can observe it in the slide also.
Methyl orange.
Methyl orange. Okay, so then after adding the methyl orange to the solution, it will turn to pink and at the end point, it changes to yellow or colorless. Okay, so please carefully observe the color change and you have to include this color change in your observation part. Right? So can you all able to understand the procedure?
Yes, ma'am. Yes, ma'am.
Okay, so I will call one person to tell the summary of the procedure, right? Okay. AG051.
Yes, ma'am.
So can you please tell the procedure for this practical? Because you are not doing as physical, no? That's why I'm asking the procedure again.
Get the soil colloid. Then
Okay, you can continue. AG051, are you there?
Yes, ma'am.
Okay, so can you tell the procedure?
Take the soil sample, then ammonium acetate,
Okay.
leached muffin,
You can go through the slide and tell me. Okay, first you have to take some amount of soil, around 1 gram of soil, and then you have to add ammonium acetate.
then transfer the porcelain basin using
Immediately after adding ammonium acetate, you have to transfer that to the porcelain.
No,
So then,
hot plate.
okay, after
heating
getting the leach, you have to evaporate that one in the hot plate.
plate, then transfer the content by them using porcelain basin.
Okay. So you can use hot water or glacial acetic acid. Okay, it's necessary. Yeah. Okay, then you have to place that
ignite.
Yeah.
Ignite the residus by muffle burner.
Okay.
Then ignite the sample. Then cooled. Then dissolve by HCl because convert the oxide into Cl minus ion.
Okay.
Chloride ion.
Okay. Very good.
Then cover the crucible because avoid the HCl evaporates.
Okay.
Then
So if you take crucible, you can cover it by lid.
Cover it both glass or lid.
Okay.
Then digest on water bath. Provide the uniform temperature. Then titrate using methyl orange titrate. Endpoint
as an indicator. Methyl orange as an indicator.
Color change yellow.
Ammonium hydroxide, right?
Ammonium.
Okay. Okay, very good. Okay, thank you, 051. Okay, I hope you all clear about the procedure, right? Do you have any doubts? Any doubts? Is it difficult to study in online?
Yes, ma'am.
Yes. Okay. Okay, if possible, we will try to do as physical, okay? So because you all know the procedure and calculation part now, so if you give some time after starting the physical lecture, you can do it as a physical. physical practical, right? Only one time you experienced doing titration, right?
Yes, ma'am.
Okay. So in this semester, I think 2 or 3 titration practicals. Okay, you only did one titration. Okay. Let's see what will happen. Right? Okay. So then, shall we move to the calculation part?
Yes, ma'am.
Okay. So here I gave all the readings for your calculations. Just you have to use these things and do the calculation part. Okay, so this time I will do one example for you and then you can do it for other readings. Okay, I will give another readings for your calculation. Okay. Okay, so here you took around 0.2 m of HCl. The molarity of HCl is 0.2 m. That means 0.2 mole decimeter minus 3 liter. Okay, so this volume is added to convert that oxide into chloride. Okay, so 20 milliliter of HCl that is added in the initial time. Okay, so then the molarity of the ammonium hydroxide that is used for the titration is 0.1 m. Okay, and these are the readings for the blank test and for the test. So you all know how to do the blank and the test. Okay, so here we have to get the average volume and we have to use that average volume in the calculation. Okay, so that means 16.3 plus 16.4 plus 16.2 divided by 3. Okay, so what is the average volume?
60.3.
16.3. Okay, so then volume of NH4 for the test average. Average volume.
15 milliliter.
Okay, 15 milliliter. Okay, so these things you have to be careful when you're doing the calculation. Okay, so if we will give 4 or 5 readings, you have to get the average of those readings and you have to use that average volume. Okay, so we are taking so many readings to reduce the error. Okay, so when you are doing the titration, you will make some error, no? Okay, for that we are taking so many readings and get the average readings. Okay, so when you are doing the calculation, please be careful. Okay. Okay, so you have to note the readings and then after that you have to do the calculations. Okay, so before the readings you have to include observation part. Okay, so what is the observation?
Color change, green color change to color change yellow.
Yeah, here you can observe the yellow color. At the end point, you will observe yellow color. Okay. Okay. Here we are going to find the reacted moles of HCl. Okay. So to find out the moles of HCl, we have to use one equation. Okay. So what is the equation to find out the mole? The basic equation. Concentration is equal to moles over volume. Okay, so to find out the mole, you can directly multiply the concentration into volume. Am I correct?
Yes.
Yes, ma'am.
Okay. So you already know the molarity of the HCl and the initial amount of HCl that added to that leachate. So you all know that one. Okay. So 0.2 m, that should be multiplied by 20 milliliter. Here you have to convert the 20 milliliter into liter. Okay, so for that you have to divide it 20 by 1000. Right? Then you will get this answer, 4 into 10 to the power minus 3 mole. Okay. So up to this, are you all clear?
Yes, ma'am. Yes, ma'am.
Okay. So after getting this mole, we have to know the mole ratio between the ammonium hydroxide and HCl. Okay, so this is actually 1:1 mole ratio. So you have to know this equation also. Ammonium hydroxide that is reacted with HCl and produce ammonium chloride and HCl. Okay. So here we can take the amount of ammonium hydroxide that is required to titrate the HCl that is equal to the remaining mole of HCl. Okay, so we are adding HCl to convert the cation oxide into chloride. Okay, so through the titration, we are going to determine the remaining mole of HCl. Okay, so we can't find the reacted one now. In previous oxidation titration reaction or titration also we did like that, unreducted amount. Okay, so likewise here also we are doing same. Okay, so the mole ratio is 1:1. So you can simply do the calculation. Okay. So you have to do it for the test and blank. Right? So are you clear about this one? Amount of NH4OH that is required to titrate the HCl is equal to the remaining mole of HCl. Can you understand this one?
Yes, ma'am.
Okay. So you can use that equation. N is equal to concentration into volume to find out the moles. And you can directly deduct from the initial amount. Right? Here I did for one example for the test and blank. Okay, for the test, molarity of the ammonium hydroxide you took for the titration is 0.1 m. Okay, and the average volume you got for the titration is 15 milliliter. Okay, so this is the volume of ammonium hydroxide that is needed to titrate the HCl. Okay, so this is 15 milliliter average volume. Okay, so then you can directly multiply 15 milliliter into 0.1. Okay, so to convert the milliliter into decimeter, you have to divide it by 1000. So here I mentioned as 10 to the power minus 3. Okay. So are you all clear about this calculation?
Yes, ma'am.
Okay. So then you can find out the reacted moles of HCl. You already know the initial amount. Okay, mole of initially added HCl. Okay, so that is 4 into 10 to the power minus 3 mole. Okay, so with the titration, we can find out the remaining amount of HCl. Okay, so we already know the initial amount and the remaining amount. So with that, we can find out the reacted amount of HCl. Okay, that means the HCl that is needed to convert the oxide into chloride. Okay, so it is very simple now. Just you are going to calculate the moles. Okay, so are you clear about this calculation for the test?
Okay, ma'am.
Yes, ma'am.
Okay. So likewise, you have to do it for the blank test. Okay, so the molarity is same, 0.1 m. Here the volume of ammonium hydroxide is varying. Okay, so this is also the average volume, 16.3 milliliter. Okay, so to find out the remaining amount of HCl, you have to multiply the concentration into volume. Okay, so then you can get the answer 1.63 into 10 to the power minus 3. Okay, so like the test, you can get the reacted moles of HCl. The initially added HCl mole is same, 4 into 10 to the power minus 3. Okay, so then you have to deduct the remaining mole, that is 1.63 into 10 to the power minus 3. Okay, so this amount that is used for the blank test. Okay, is it okay?
Yes.
Okay. Okay, so with that, we can find out the total amount of HCl that is reacted. Okay, for that you have to deduct the mole of test and blank. Okay, you already get the reacted moles of HCl for the blank test and the test. Okay, then you have to find the total reacted amount of mole of HCl by reducing the blank mole of HCl from test. Okay, so you have to reduce the 2.37 into 10 to the power minus 3 from 2.5. Okay, so from that you will get one answer, 0.13 into 10 to the power minus 3. You all know the unit for the cation exchange capacity, right? So what is the unit?
Yes, ma'am.
Sorry? What is the unit for the cation exchange capacity?
Centimole.
Centimole? Only the centimole? You already told total exchangeable cations that is present in a unit weight. Right? Only the centimole?
Centimole per kilogram.
Okay. So the unit of cation exchange capacity is centimole per kilogram of soil. Here we find out as mole. So we have to convert the mole into centimole. You all know 1 mole is equal to 100 centimoles. Okay, so then you can directly multiply by 100 and then you get an answer 13 into 10 to the power minus 3. Okay, so this is the reacted mole of HCl. Okay, so that means the HCl that is needed to convert that cation oxide into chloride. Okay, so with that we can find out the total exchangeable bases. Okay, so you can directly use this reading, the reacted mole of HCl. Okay, 13 into 10 to the power minus 3. Okay, you already take 1 gram of soil and then you have to find it for the 1 kilogram of soil. For that, you have to divide that by 1 gram and you have to multiply by 1000. Right? Then you will get the answer in 13 centimeter mole per kilogram of soil. Okay, are you all clear about these things?
Yes, ma'am.
Okay, so to find out the total exchangeable bases, you can directly use the reacted mole of HCl. Okay, so you all know HCl is used to convert the cation oxide into chloride. Okay, so that's why we can use that mole directly to find the total exchangeable bases. Okay, so previously we took for 1 gram of soil, so we have to find it for 1 kilogram of soil. Right? So after finding these total exchangeable bases, you can find the base saturation. So what is the equation to find the base saturation? Anyone of you? Can you tell me what is the equation? No one knows the equation? I think in the introduction part I told. 096. Are you there? No. Okay, then can you all please raise your hand? Okay. Okay, then 165.
Yes, ma'am.
So can you tell the equation for the basic saturation, base saturation?
Proportion of basic cations in percentage. To the total cation in the on the
Soil.
complex.
Okay, so you can simply say total exchangeable bases that should be divided by cation exchange capacity and then you can multiply by 100. Okay, just a simple equation. So please note it down. Total exchangeable bases divided by cation exchange capacity and all the things multiplied by 100. Okay, so please remember the equations. Okay, so then you know the total exchangeable bases. And here I gave the readings for the cation exchange capacity as 16.025. Okay, so you can use this data for the cation exchange capacity. Right, then you can find the base saturation. Okay, so do you have any doubts? Okay, here in the readings you can include the cation exchange capacity also. Okay, 16.025 centimeter per kilogram, right? Okay, so are you all understand the calculation?
Yes. Yes, ma'am.
Okay. So now I will give some time to do the calculation. Okay, so everyone, you have to send me your answer to me. Directly send the answer to me. Okay, I will give around 5 to 10 minutes. Okay, so please copy down the readings first. Everyone, you have to send me the answer directly, okay? Don't send it for everyone, send me directly. If you copy the readings, please let me know, right? Okay, sorry, blank B1 reading is 18.3, okay? That one I read 18.3. Did you all take it down the readings? Yes or no?
Yes.
Yes.
So then I will give 5 to 10 minutes to do the calculation, right? So everyone, you have to send me directly in the chat box, right? If anyone finish, you can directly send me. Okay, good. Some of you are sending the answer, right? Okay, good. You can send the base saturation and also the total exchangeable bases, right? Okay, you are giving so many different answers. Let's see.
(6.25 into 10 to the power minus 3).
Okay, so did you all get the same answer?
Yes, yes.
Okay, 6.25. Okay, so then for the blank test, What, 8.? 8.6. Okay, any other answers? Because I don't know, I didn't calculate the answer. So the average volume is 18.3, right?
Yes.
Okay. So then the HCl mole. Is it okay? Any others get different answers? Because you all are getting different answers. Yes? $2.59. Okay, so others, are you all agree with this answer or any other different answers?
Agree.
What?
Same answer, ma'am.
Same.
Okay, so 2.59. Is it okay? Others?
Okay.
You have to multiply the 18.3 into that molarity of NH4OH. Okay, so then you have to subtract the value from the initial. Okay, so are you all got that answer? Anyhow, all are sending different answers. Okay, so what will you get for the test? Remaining amount of HCl for test.
3.45 into 10 to the power minus 3 mole.
3.45. Is that correct? Because
Yes,
I'm okay. So then what is the total exchangeable basis? Is it above 80?
86.
86. So all of you agree with these answers?
Yes.
Yes, ma'am. Yes, because some of you didn't get the answer. That's why I'm asking again and again. Okay, so then the base saturation. Yeah, I gave the cation exchange as cation exchange capacity as 27 centimole per kilogram. So you have to divide that 86 by 27, and then you have to multiply by 10. Okay, so the final answer is 31, right?
Yes, ma'am.
Okay, so 31 point some decimal values. Okay, so are you all clear about the calculation part?
Yes, ma'am.
Okay, so you can do this calculation. Okay, no need to do the previous part. Right here. Okay, so no need to copy this reading. Okay, you can only do the calculation for this one. Okay, readings for your calculation. Okay, so no need to copy that one because we will upload this slide to you now. So no need to copy down that one. Okay, so just use these readings and you can write the calculation. So you already did the calculation as rough. You have to record that one in your practical record. Okay, so I'm telling you again, you need to write this reading. Okay, so from slide number 8, you no need to write. Okay, so just you have to do the calculation for this readings for your calculation. Okay, Okay, so after that, you have to write a conclusion. So what is the base saturation for your given soil? Okay, so it will come as 31.48, no? Okay, then you have to interpret your results. Using this table, you have to interpret the results. Okay, I think it will, the basic base saturation, it will come between the 20 to 40, right? So the grade is low. Okay, so for this soil, we need to do any management practices? This base saturation percentage is high, we need to do some management practices. Okay, here it is a very low condition now. Okay, so no need to do any management practices. If that particular cation is needed for the growth, we have to add it by the application of fertilizers. Right, so you have to copy this table and you have to interpret the results. Okay, just you can write a low or moderate or high. I think it is come under low grade. Okay, so the conclusion part is very much important. So you have to include these things in your conclusion. Okay, and for your discussion part, I already discussed all these things while telling the procedure, right? So you have to include all these things and you have to submit the record book. Okay, I think submission is tomorrow. Because none of you, I think only few of you submitted the previous practicals. Around 48 or 50 students submitted. So do you have any problem in submission? Due to traveling, you couldn't write the practicals. Is it? Okay. I think around 129 students submitted the previous practical. 129, 28, 27, 24, like that. Okay. For the late submission, we will reduce the marks. And for no submission, we will not give marks. Okay. So for 13 practicals, we will get the average and we will add for your final exams. So please consider that one and submit your practical books in a proper manner. Okay, I already told to submit the PDF as a clear format. If it is not clear, I will not give the marks to you. Okay, so you are not children, no? You are undergraduate students. You can check the PDF after taking the photos. Okay, and you have to do the calculation part and then you have to give the proper conclusion. Some of you didn't include the calculation part. After telling also, some of you didn't include the calculation. You just copy the slides that we uploaded. Okay, so after that we gave some readings and you have to do that calculation. Okay, I already gave one morning and this is the second morning. After onwards, we will not provide high marks to your practicals. Okay, you can simply score marks from your practical book submission. No need to study. Just write the notes and you have to do only the calculation and discussion part. We will just give A or A plus to you if you write it properly and submit. Okay, so when you are submitting the practical PDF, Please be careful. Okay, and submit it as a clear format. Okay, I all got that point. It's so difficult to correct all the practical PDFs in the laptop. If it is not clear, we can't read your things, no? Okay, so please be careful, and when you're uploading the previous practical, you have to attach that graph also, right? For the plastic limit and liquid limit practical, you have to scan that one and you have to upload that one. Okay? Did you all got that point?
Yes.
Okay. Okay, some of you ask, ma'am, whether we have to multiply with 100 or 10 to get base saturation. Okay, here the base saturation we are giving in a percentage. Okay, so for that we have to multiply by 100. It will come as 31.48, right? Answer is coming as 300. Get same problem?
Yes, ma'am.
Okay, so thank you. I will change the readings. Okay, so we didn't do the practical, no? Just we are giving the readings as random. Okay, otherwise you can use the previous readings. Okay, to calculate that one. Right? So this part you no need to do. This slide. Okay, I will, so otherwise I will send it again. Thank you. I just changed the readings and give it to you. Okay? Okay, sorry for the inconvenience. Only one student tell me that problem. Okay. Okay, so no need to change it as 10. You have to multiply into 100. Okay, so the base saturation equation is total exchangeable bases that should be divided by cation exchange capacity, and you should multiply by 100. Okay, so this is the percentage. Okay, others you all multiply by 10 and you told me the answer, right? Is it? How did you get that 31.48 something answer? Others who got 31.48? How did you get that answer? That's not an accurate one. Am I right? So we couldn't actually find out the relative percentage of sand, silt and clay by the field method. So that is one of the demerit using this method. Did you understand that one? When we are predicting the soil texture by the field method, that is not accurate. Okay, so we didn't analyze the sand percentage or silt percentage or clay percentage. Just we are doing some procedure and just we are predicting the texture of this soil. Okay, so this method is not accurate. Okay, and also this may be vary with the person, right? So there is a personal error. Okay, so to overcome all these problems, we can do a laboratory analysis to find out what is the texture. Okay, so that one we will study in the next class. Okay, laboratory method is using the pipette or hydrometer method. Okay, so determination of texture we can find by the laboratory method or by field method. Okay, so in these practicals we are going to see how to determine by field method, and next week we can study the pipette method, right? So why we need to check the texture? What is the purpose?
Planting purpose.
Sorry,
Planting.
I couldn't clearly hear you.
For the easy root penetration.
Root penetration. Okay. Any other answers?
Into the irrigation.
To schedule the irrigation. Okay. Any other answers?
Nutrient retention capacity.
Okay, nutrient retention capacity. Then any other things? Infiltration capacity? Sorry, can you repeat it again?
Land preparation methods will be different according.
Okay, land preparation method, right? Any other thing? Okay, we can predict or we can tell other things or other properties of the soil using the texture. Okay, so can you tell the size of clay particles? You all studied that USDA classification and other basic classification, right? Okay, so those are clay particles, clay soil. And for the sandy soil?
0.2
0.2
to 2 millimeter.
Okay, 0.2 to 2 millimeter. Okay, I'm asking the USDA classification. Right, okay. For the silt soil?
Between 0.02 to
0? Right. These things you already studied in your theory, right? Okay, so you can refer and you can include in your discussion parts, right? So those are the theoretical things. So here in this practical, just you're going to use your hand for the analysis, right? And you all know, so there are different textural classes found in the earth. Okay, here in this picture, you can see the textural triangle. Okay, you can see each and every side of the pyramid. You can see the sand, silt, and clay percentage. Okay, so using the percentage of these different types of soil, we can find out the texture. Okay, so we will see how to find out the texture using the textural triangle in the next class. Okay, so this will comes to your spot exam. We will place the textural triangle and we will give some data to find out the texture. Okay. So did you study the textural triangle in your theory part?
Yes, ma'am.
So can you tell me what did you study?
With the help of
Okay. So I will give an example to you. Can you tell me the texture? Is it difficult to find? Okay. So the sand percentage is 30. Okay, then the silt percentage also 30. And clay percentage also same, 30. All are 30 percentage. For your easiness, I am giving that one. They mean, okay, you can just tell me that one.
clay loam.
Okay, very good. Clay loam. So you all know, no, using this axis, for example, I gave 30. So you have to check 30 percentage in the sand and then 30 percentage in the clay, right? And 30 percentage from the silt, right? So here you can observe that clay loam soil. Okay, likewise you can find for other textures also. Okay, so this is for one of the example. 30 percentage, 30 percentage, 30 percentage. Okay, so I hope you all are clear about how to find this texture using the textural triangle. Right, so you can easily score some marks in your spot examination. So we will just place this triangle and we will ask what is the purpose of using this triangle, what will we do and how to find out the texture by using this triangle. And one example, we will give some range of sand, silt, clay, and then we will ask what is the texture of the given sample. Okay. Okay, so please remember that, and within 2 minutes you have to find out and you have to write the answers. Okay, I told one spot for your final exam. Right? Okay. So can you tell me the different textural classes?
Sand. In the sand, loam is sand, sandy loam.
Okay.
Loam. Sandy clay loam.
Okay.
Clay. the clay soil, clay loam,
Clay loam. Okay. So there are so many textural classes. Then there is a standard procedure or standard thing to find the texture by feel method. Okay, so these things I already mentioned in the introduction. Okay. Here they followed some standard method or standard procedure to find out the different textural classes. Okay, if we give or if we place some, for example, you have to feel it by your hand and you have to tell what is the texture of that soil. Okay, so using this data you can tell. Okay, anyone can you please read this slide? These things you studied in your theory also. Right? Did you study? Did you study or not?
only sand, ma'am.
Only sand?
Not tiles.
Not for all the textural classes.
Yes, ma'am.
Okay. So these things not available in your theory notes. Is that so? Yes or no? Okay, so how you can identify the sand texture?
By visible.
Sorry, I couldn't hear you.
Loose and single grain.
Loose and single grains. Okay, then what will happen when you're adding the water?
Not absorb the water.
Okay, it will not absorb the water. And here they told about when you add the water, some will wet, no? It will infiltrate quickly the water, but when you are adding some amount of water will absorb. Okay, so it will fall apart when you squeeze it by your hand. Okay, so sandy soil you can easily identify by your visual observation. Right? So then for the loamy sand, what is the difference? You can use this slide and you can tell me the answer. No need to memorize all the things, just you have to know. So it is also looks like sandy soil, right? Single grains. Okay, so what is the difference you will observe when you wet that soil?
When we wetted, cast will not form apart.
Cast will not form. Then what will happen? If you open the hand, what will happen? that cast will break. Okay, so I will show a simple video, just the procedure. Okay, you can go through these slides and you can get an idea how to find the texture by field method. Okay, so it should be if it is a practical, we can do it as a physical one. Anyhow, you can do it at your home. Okay, so you can get the different soil samples from different places and you can check it. It is a loamy sand or clay soil or sand. You can check, no? At home level. You don't need any chemicals or any other instruments to find the texture. Right? Just you need some amount of water and some amount of soil. Okay, so you can try it at your home. Right? Is it okay to try at your home?
Yes.
Okay.
Okay, so I will ask you in the next class. Okay. Here in the laboratory procedure, we have to take around 10 gram of soil. Okay, at home you can take some amount of soil. Okay, and you can add some water and you can feel the texture. Okay, so here the simple flow chart that will explain to you how to find the texture. If you place so many samples, it's difficult to find out the texture, no? So for that, they gave one standard flow chart. So these things I got it from one research paper, right? So they are taking different amount of sample. Here they took I think 25 gram of soil. Okay, so the amount of soil is not a problem to find the texture. Okay, so no need to confuse that one. Okay, so if you go through the slide, you will get an idea. Okay, so I will play the video. So can you able to see the video?
Yes, ma'am.
Yes, ma'am.
Okay. So they are using spatula, but no need that one. Okay, so first they are making a bowl. Okay, if it is that bowl is not formed, we can tell it as the sandy soil. Okay, likewise they are doing other steps. So they are going to make it as a ribbon. Right, if it is from the ribbon, we can tell it as loamy sand. And the length of the ribbon and how long it will persist. With that, we can tell other types of loam soil. Okay, so you can observe all things in one frame. Some of you can't see the video because of poor signal. I will share the link with you, okay? So you can go through that one and get an idea to find the texture by field method. Okay, so this is the very basic method to find the texture. Gritty or like sugar, sand. Okay, I will stop with this, okay? So did you get an idea about this practical?
Yes.
Okay, so are you all try to do at your home?
Yes, ma'am.
Okay. So in this practical, you don't need to include any discussion part, right? Okay. Just go through your theory notes. Okay, for the USDA classifications and other classifications, you go through the theory notes. Okay, no need to include any conclusion or discussion part for this practical. Right? Just you have to write the procedure and other things. Okay, this slide also needed. Okay, so I gave it for your understanding. Okay, to get an idea, I will give this slide. Okay, no need to copy this flow chart in your practical copy. Okay, so up to this slide, enough. Okay, so up to procedure. Here we will not give any solve samples, no? If you try at your home, you can write the conclusion part, but for everyone it will change. No, the conclusion it changes. Okay, so up to procedure, enough for this practical. Okay, so you have to write it in passive form. Okay, so please go through the video and get an idea how to find the texture by field method. Okay, so do you have any doubts? I know it's somewhat hard to study in online, but anyhow, you have to study, no? Otherwise, it will take more time to finish your degree. Okay, if anyone want this practical video, you can contact me, okay? If you want to contact me, you can get the number from your rep and you can directly contact me. Okay, if you have any network issues or other problems, absentees, okay, you have to tell me the proper reason. Only I will share the video. Okay? Do we need the video recording? Others? We will upload the notes. From that, you can get that video link also. If you want, we can share, but you have to tell me the proper reason. Okay, so if you want, you can get my number from your rep and you can contact me, right?
Okay, ma'am.
Okay. So if no doubts, you can leave.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank